Okay, so I want to look at this probability question. This is a counting question. We want to know in how many ways can we divide 15 students into 4 rooms so that 6 students, 4 students, 3 students, 2 students are going to be put in the rooms A, B, C, D, respectively. So we're trying to put 6 students in room A, 4 students in room B, 3 students in room C, and 2 students in room D. Now these 6 students are different from these 4 students, and these 3 students are different from these students. These 2 students are different from these. These are all different students. So we're not putting the same student in 2 different rooms. So these are separate students. So, okay, and now these 6 plus 4 plus 3 plus 2, that adds up to the 15. So we're just breaking apart the 15 students and putting a bunch of them in different rooms. So we want to know how many ways can we do that. So we're going to assume for here that ordering in each room doesn't matter. So this is not a permutation question where we're trying to find how many orderings. So this calls for a combination question. So let's take a look at what we could do. We have 15 students. For room A, we're going to be putting 6 students. How many ways can we put that? Well, that's going to be 15 choose 6. Okay, so the answer, 15 choose 6. All right. So now once we get to the second room, we already have 6 students put there. So we're picking 4 students, but we only have 15 minus 6, which is 9. There's only 9 students left to choose from. We're going to be putting any 4 out of the 9 left. So that's 9 choose 4. Okay, and now we multiply this because of the multiplication principle. Okay, and now we picked 4, we picked 6. We picked 10 students already. We had 15 students, so we have only 5 students left, and we're going to pick 3 to put 3 out of any 3 students out of the 5 that are left. That's 5 choose 3. Okay, again multiply. And the last one, we already picked 6, 4, and 3. We only have, that's 7, 13. We had 15. We only have 2 left. So the last 2 students that are left are going to be put in room D. So let's say 2 choose all the 2. So this is the answer to the problem. Okay, we're using combinations. So again, this is going to tell us for room A how many ways we could pick 6 students out of the 15. Here's how many ways we could pick any other 4 students that are left out of the 9 that are left. This is how many ways we could pick 3 remaining students out of 5 that are left, and here's how many ways we could pick the 2 students that are left. Okay, now let's actually compute out all of these. Let's write out using the combination formula. So with combinations, when you're finding n choose k, okay, it's equal to n factorial over n minus k factorial times k factorial. This is the combination formula. Okay, so let's write this out. 15 choose 6 is going to be 15 factorial over n minus k is 9 factorial times 6 factorial. 9 choose 4 is going to be 9 factorial over 9 minus 4, 5 factorial times 4 factorial. The next one, 5 choose 3, is going to be 5 factorial over 2 factorial times 3 factorial. And the last one is 2 factorial over 2 minus 2 is 0 factorial times k factorial times 2 factorial. Okay? Now, 0 factorial, that's just 1. So we can just get rid of that. That's 1. Okay, now if you notice, there's an interesting pattern here. That a bunch of these factorials, we have the same factorials on the top as we have on the bottom. A bunch of them are going to cancel out. So the 9 factorials cancel with this one. 5 factorials cancel. These 2 factorials cancel. And that's it. So let's simplify what we have left. Okay, at the top we only have 15 factorial in the numerator left. On the bottom we have 6 factorial, 4, 3, and 2. Okay, so this is the formula we're using, and we simplify to this. This is going to be the answer. Now, if you notice, look at the denominator. These 6, 4, 3, and 2, these are the same exact numbers we had there. These add up to 15. So what this problem is trying to say is that when you have a problem just like this, when you have a certain number of students, you want to divide them into 4 sections, four different groups, where one group is going to have 6, one has, let's say, 4, 3, and 2. They have various amounts of those groups. The number of ways that this could happen is going to be, the numerator will be the total number of people that you're starting with, factorial. Then you're going to divide it by the product of the individual number of people that you're going to be putting in each group with factorial, each one. Okay? This is actually called the multinomial coefficient. Okay? This is called a multinomial coefficient. So this is trying to say when you have n elements you're starting with, okay, and you want to divide up, you're splitting the n elements into different groups. So let's say you're going to split it, you're going to have n1 is going to be in group 1, n2 you're going to have this, and these are going to be how many people, n2 number in group, going to be in group 2, and so forth, up to to nk you're going to place in group k. Okay, so we're splitting them up into different groups. And the n1 plus the n2, all these numbers of people add up to n. So if n1 plus n2 plus nk equal n, the number of ways that this could happen to do this is the multinomial coefficient, okay, which is going to be, the formula is n factorial divided by n1 factorial times n2 factorial to nk factorial. Okay, so that's what we're showing here. When you're splitting up n objects, elements, you're putting a certain amount into each group, where these numbers are referring to different objects into k groups. As long as these elements add up to the total, the number of ways is this formula here, which is the multinomial coefficient. Okay? Thank you.